Red Bull sells over 9.8 billion cans annually worldwide. But have you ever wondered what actually goes into each one? The ingredient list cites taurine and glucuronolactone, yet most consumers have no idea what these compounds are or where they originate. In this exclusive documentary, we take you inside Red Bull's tightly guarded production plants to reveal the surprising truth about how this global energy sensation is made. From precise chemical formulas to high-speed lines that fill 1,500 cans per minute. You're about to see what happens behind closed doors. Welcome to the raw ingredient storage area, where Red Bull begins its journey from simple components to a world-famous energy drink. This vast space is packed with enormous stainless steel tanks and climate-controlled silos, each holding the exact building blocks that will one day fill billions of slim cans. Temperature and humidity here are rigorously controlled to preserve ingredient integrity from the moment they arrive. Let's start with perhaps the most misunderstood component, taurine. Despite decades of rumors, taurine in Red Bull has nothing to do with bull's anatomy. Its name does come from taurus, Latin for bull, because it was first isolated from ox bile. However, the taurine in your can is completely synthetic, produced in pharmaceutical facilities. Under a microscope, it appears as intricate crystalline lattices resembling tiny snowflakes. Contrary to popular belief, taurine isn't an energy stimulant. Rather, it suppresses excitatory neurons in the brain, delivering a calming effect. Quite the opposite of what most expect. Moving deeper into the plant, we find the caffeine storage zone. Unlike coffee shops that extract caffeine from beans, Red Bull uses lab-made caffeine delivered as a fine white powder akin to baking soda. Even a few milligrams variance can alter the drink's performance, so this powder is handled with pharmaceutical-level precision. Consistency across billions of cans demands nothing less. Next is the B vitamin section, home to niacin, B3, pantothenic acid, B5, pyridoxine, B6, and cobalamin, B12. These concentrated vitamins arrive in sealed drums and are carefully diluted. They aren't random additions, but are calibrated to boost energy metabolism, support immune function, and regulate the nervous system. Formulations vary slightly by region to meet local regulations, requiring bespoke mixing protocols. Behind reinforced doors lies what may seem mundane, yet is the lifeblood of every can. Water. Sourced from the pristine Austrian and Swiss Alps, one of the world's largest freshwater reserves, Red Bull's water undergoes multiple stages of filtration. This near-obsessive purification guarantees uniform mineral content in every batch. Alpine water is passed through progressively finer filters, UV sterilization, and mineral adjustment systems before it's deemed suitable as the drink's base. The sweetener area is equally impressive, with separate lines for regular and sugar-free recipes. Each sweetener batch undergoes spectroscopic and density testing before approval. Specialized sugar crystals are measured for precise dissolution rates, which influence both taste and mouthfeel. The glucuronolactone storage may hold Red Bull's most enigmatic component. This naturally occurring compound, found in connective tissues, is far less discussed than taurine, yet performs vital physiological roles. Like taurine, the glucuronolactone in Red Bull is synthetically produced rather than animal-derived. Quality control stations pepper the facility, where technicians in lab coats perform both automated and manual tests on every ingredient. Digital dashboards track everything from microscopic contaminants to exact chemical ratios, ensuring nothing reaches the mixers without meeting strict criteria. Once ingredients pass inspection, they enter an industrial wonderland of precision engineering. Beyond massive steel doors lies a labyrinth of gleaming tanks and custom equipment, the apex of beverage manufacturing. This network is so finely tuned, it can detect irregularities smaller than a human hair, all while churning out enough drink to quench the world's thirst. Industrial pumps drive ingredients through this metallic maze under digital flow rate controls. Nothing here is left to chance. Every valve, sensor, and gauge exists to guarantee absolute consistency. The mixing sequence is a carefully choreographed ballet. Purified water and sugar first merge in primary tanks, forming the base solution. Engineers watch real-time data on density, temperature, and dissolved solids. Only when each metric hits its target does the system introduce acids, taurine, caffeine, and other actives in precise intervals. Temperature control is paramount. Cooling jackets filled with glycol envelop the tanks, allowing rapid adjustments within fractions of a degree. This precision prevents heat-sensitive compounds from degrading and ensures the final taste profile and efficacy remain unaffected. Next comes carbonation, the hallmark of Red Bull's effervescence. In pressurized vessels built to withstand multiple atmospheres, carbon dioxide is injected under controlled conditions. Engineers balance pressure, temperature, and contact time to hit the ideal carbonation level. Too little yields a flat drink, too much risks can rupture. Throughout, automated QC units sample the liquid, measuring pH, sugar content, carbonation, and ingredient ratios in real time. Any deviation triggers immediate correction or diverts the batch for reprocessing. After mixing and carbonating, the liquid passes through a flash pasteurization system, a critical yet often overlooked safety step. Heated for milliseconds to eliminate microbes without altering flavor, this stage is monitored within 0.1 degrees Celsius precision. It both sanitizes and extends shelf life. Even a tiny overheat or excess dwell time could change the taste Red Bull drinkers expect. The technology behind these steps embodies decades of engineering progress. When Red Bull launched in 1987, production was semi-automated with heavy human oversight. Today's plants are fully computerized, monitoring over 100 parameters, from tank pressure differentials to microscopic flow variations. Modern Red Bull factories meld food science and industrial automation to near perfection. The final transformation is the slim can itself, an engineering feat few appreciate. Empty aluminum cans arrive by the thousands on high-speed conveyors into a clean room environment that rivals hospital HVAC standards. Advanced filters remove particles down to 0.3 microns, protecting product integrity. This level of cleanliness is essential to prevent contamination. Red Bull Slender can design nearly derailed early production. Standard filling lines couldn't handle its unique dimensions. So engineers devised wholly custom machinery, unlike anything in conventional beverage plants, requiring massive investment to perfect. Each empty can undergoes intense scrutiny. High-speed cameras capture images of every container, detecting microscopic defects invisible to the naked eye. Damaged rims, pinprick punctures, or internal contaminants. Any imperfection triggers immediate ejection from the line. Surviving cans enter the critical zone at the filling station. First, each can is purged with nitrogen to remove oxygen and prevent oxidation. Then the formula flows in under carefully controlled pressures and flow rates. This is not mere pouring, but a finely tuned process, ensuring uniform fill levels across thousands of cans per hour. Once filled, precision-seaming machines apply the pull-tab lids in a two-stage operation that rolls and crimps the edges to form an airtight seal measured in thousandths of an inch, preserving carbonation until you crack it open. Quality verification never stops. Sealed cans pass through multiple checkpoints, including weight check stations that detect variations as small as 0.5 grams. Leak testing equipment applies pressure to spot microscopic breaches, while 360-degree imaging systems seek any external flaws. Laser coders then mark each can with batch numbers and expiration dates, providing full traceability from factory to consumer to facilitate rapid recall if needed. From raw inputs to the finished can, the line comprises over 30 distinct stages, each under constant QC oversight. Filled cans are automatically case-packed, palletized, and moved to temperature-controlled storage, awaiting dispatch. Once shipped, Red Bull's global logistics network takes over. Refrigerated trucks and specialized containers maintain optimal conditions to distributors across more than 171 countries. Advanced tracking systems let the company monitor shipments in real time, optimizing routes to cut transit time and environmental impact. As our tour of Red Bull's production draws to a close, we've seen a complex symphony of technology and precision few consumers ever contemplate. Behind that slim aluminum can lies not just an energy drink, but an engineering masterpiece coupled with a sophisticated global supply chain. Red Bull's sustainability efforts mirror this attention to detail: 100% recyclable lightweight cans and energy-efficient plants, proving innovation extends well beyond the formula. The next time you take a sip, remember you're tasting more than a drink. You're experiencing a triumph of modern food technology.